Hello guys, how are you today? So today I'm going to be explaining the math section 4.5 because I know for grade 11 we don't have this exam today, which is November 16, 2025, but for the grade 10s haram because they asked me to. So anyways, I'm going to start with question 1. I'm just going to do it very quickly. I submitted put any answer and I'm going to solve it, okay? Consider the following. Y equals fx equals 6x to the power of 4 over x to the power of 4 plus 7. Select all that apply. As x approaches infinity, when we're dealing with something like this, what we need to do is we need to take the highest exponent with the highest exponent. So it's going to be 6x to the power of 4 over x to the power of 4, which will just give me what? Which will give me 6. So as I approach plus infinity or minus infinity in my x, I'm going to get the same answer, which is what? Which is 6, okay? So you take the highest exponent with the highest exponent, you simplify, and then you substitute plus infinity, minus infinity. Here, because I got a whole number, it doesn't matter if I put plus or minus infinity, it's gonna be the whole number itself. I'm gonna move on to question number 2. What does it say? Consider the function y equal fx equal 4x cubed minus 8x squared. So you take the one with the highest power. Then I substitute 1 time plus infinity, 1 time minus infinity. 4 times plus infinity to the power of 3, that's gonna give me plus infinity. 4 times minus infinity to the power of 3, that's gonna give me minus infinity. So if I put instead of x plus infinity, it will give me plus infinity. If I put instead of x minus infinity, it will give me what? It will give me minus infinity. I'm gonna move to question number 3. What does it say? It says consider the following function. Again, it's the same exact thing. So what are you supposed to do in this scenario? So here we need to read the question a little bit, and we need to read the answer. Before it's as x approaches plus infinity minus infinity. Here, as x approaches 6. What happens if we put x to be 6? 6 minus 6 cubed, that's going to be 0 cubed, and it's going to be 12x over 0, which is going to give me infinity, either plus infinity or minus infinity. Depends on what? It depends on if we're above 6 or smaller than 6. So if I choose a number greater than 6, okay? For example, if I choose 8 minus 6 will give me a positive answer. So it's going to be plus infinity. But if I choose a number smaller than 6, for example, 2 minus 6 is going to give me a negative answer. And pay attention, it's also to the power of 3. If it was to the power of an even, they would both be positive. But because it's to the power of 3, it's going to be what? It's going to be negative if I put a number smaller than 6. We move on to question number 4. What does it say in question number 4? Okay, question number 4. Consider this function. You take the highest exponent and you substitute 5x to the power of 4. 5, you substitute plus infinity, you will get plus infinity. You substitute minus infinity, you will get what? You will get plus infinity because it's to an even power. So plus infinity for plus infinity for minus. We're going to move on to question number 5. What does it say? Okay. Here, they're saying as x approaches 0. As x approaches 0, I will get what? I will get two values, which are either plus infinity or minus infinity. So, because why? Because it's to an even exponent, right? So if I choose a number larger than 0, for example, 1, I will get it to be a positive number. If I choose a number smaller than 0, for example, minus 2, I would get it to be... Or sorry, no, because it's my look, if I choose minus 5 and I put on top of it 0.02, right? What's minus 5 over 0.02? It will give me minus 250. So what? If I put a positive answer instead of x, I will get a negative value. If I put a negative value, so minus 0.02, right? So it's going to be minus 5 over minus 0.02, I will get plus 250. This plus is because I chose a negative number, okay? We'll move on to question number 6. What does it say in question number 6? Again, if it approaches infinity, so what do? I take the highest exponent, so 3x over x to the power of 5. So 3 over x to the power of 4. So if I reach plus infinity or minus infinity. In both scenarios, it's gonna be 0. How do I know? Try on your calculator. 3 over, choose any very large number. For example, 1, and put as many zeros as possible, right? Or let's make it easier so we can remember. 10 times 10 to the power of 50, okay? It's gonna give me 3 times 10 to the power of minus 51. So 0.0000, so many zeros until you reach what? Until you reach what? Until you reach 3. So it's a very small number, very close to 0. So that's why it approaches 0. If I chose a negative number, so minus 10 times 10 to the power of 50, I would get minus 0.00000 blah 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 3. Okay, so that's why plus infinity, minus infinity, I'm gonna in both scenarios approach 0. Question number 7, again, same scenario. You take the highest exponent here with the highest exponent here, so 5x5 over x4, so 5x. If I substitute minus infinity, I will get minus infinity. If I substitute plus infinity, I will get what? I will get plus infinity. And move on to question number 8. What does it say? Okay, here exact same thing. I will take x squared with x, highest exponent with highest exponent. So x, oh, sorry, here I didn't read the question. They're not taking the as you approach. Consider the function y equal fx equal blah blah blah. Okay, here you need to check. We have numerator, the biggest exponent of the numerator is greater than the biggest exponent of the denominator. Directly, we have what? We have an oblique asymptote, and for sure, always we're gonna have a vertical asymptote, okay? So here, I look at it. How do I find my oblique asymptote? I'm supposed to divide. So x squared minus x minus 2 divided by x minus 2. X squared divided by x is x. Let me change the color. X times x is x squared. X times minus 2 is minus 2x. Change the signs. Now minus x plus 2x, that's x. Now x divided by x is 1. Oh wait, I think it's plus. Yeah, my bad. Here it's plus. This is why it's wrong. Okay, it's plus. So now, when you do it, it's gonna be 3x. 3x divided by x is how much? Is 3, right? And then 3 times x is 3x. It's not gonna fit here, so I'm just gonna erase this. I'm gonna make this now x minus 2. And then it was what? It was plus 2x, right? So that becomes 3x. And then drop the minus 2. Then 3 times x is how much? 3 times x is 3x. And then 3 times minus 2 is minus 6. Change the sign, so I will be left with 0 and 4. So 4 over x minus 2 is what is my remainder. And what is my oblique asymptote? My oblique asymptote is y equals x plus 3. My vertical asymptote is now denominator equals 0, x equals 2. We move on to question number 9. What does it say in question number 9? Which of the following is true about the function f given by y equals fx equal 8x over blah blah blah? We check numerator, highest exponent compared to denominator, highest exponent. 1 and 2. Definitely numerator is less than denominator, so we only have horizontal asymptote. That is equal to how much? That's equal to 0. That means y is equal to 0. And vertical, you need to make the denominator equal to 0. So x squared is equal to 64. X is equal to plus minus 8. So x equal 8 is a vertical asymptote. X equal minus 8 is a vertical asymptote. And y equal 0 is what? Is a horizontal asymptote. We'll move on to question number 10. Okay, which of the following is the limit of plus 5 over x4 as x approaches 0? Okay, because it is what? An even exponent. If I put any number greater than 0, any number less than 0, it will yield me the same answer, which is what? Which is plus infinity. So 5 over, if I chose, for example, 0.003, right? What will I get as an answer? 5 over 0.003. Oh, don't forget to the power of 4. To the power of 4. I will get a very, 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 very large answer. Like if I put minus 0.03 to the power of 4, I will get the same exact answer. Because it's even, so plus infinity. If it was odd, it would be plus and minus infinity. Move on to question number 11. Okay, this is going to take a bit of time, but we can do it together. What is the domain of definition? Domain of definition. We have a couple of cases of domain. If we have x squared plus let me say ax squared plus bx plus c. This does not have any domain. The only times we have domain are when we have a denominator, right? For example, x over x squared, when we have a denominator, right? What would our domain be? Our domain would be the denominator is different than 0. If we have a radical, for example, x radical x squared, right? Or like radical x squared, what would be my domain in this scenario? My domain in this scenario would be x squared. Like, let me just remove the squared, so it will be like this, right? So x should be different than 0, radical x, then my domain should be x is greater than or equal to 0, and if it's a combination, meaning it's a radical denominator, then in this scenario my domain should be what? Should be that x is only greater than 0. It cannot be equal to 0 because it's in the denominator. Let me just get rid of this. Now, question 11, what does it say? It says x minus 1 over 2x plus 1, the domain of definition. So it's what? A denominator. We have a denominator, 2x plus 1. That means we should make it different than 0. That means x is different than minus 1 over 2. Now, the vertical asymptote. How do we find the vertical asymptote? Directly, you take the denominator, right? This is my vertical asymptote, and I make it equal to what? I make it equal to 0. So x is going to be equal to minus 0.5. This is what? This is my vertical asymptote. Now, for my horizontal asymptote, I check on my numerator and denominator. What's up with them? My numerator, the highest exponent is equal to the denominator. That means my vertical asymptote is going to be what? It's going to be the ones with x. It's going to be their fraction. So I have 1x, 2x, 1x over 2x. How much is that? That's going to be 1 over 2, which is how much? Which is 0.5. That means my horizontal asymptote is 0.5. Now, the graph is increasing for all values of x in the domain. So whenever they say, you open the options, increasing, decreasing, blah, 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 what do I need to do in this scenario? I will need to take the derivative. So let's find the derivative together. This is u over v. So it's going to be u prime v minus v prime mu over v squared. U is x minus 1. U prime is 1. V is 2x plus 1. V prime is 2. Okay? Now, I can find my answer. This is v squared. It's going to be u prime v, so 1 times 2x plus 1, minus v prime u minus 2 times x minus 1, over what? Over v squared, over 2x plus 1 squared. So this is going to be 2x plus 1 minus 2x. So minus 2x plus 2. So this and this go. And I'm left with what? I'm left with 3 over 2x plus 1 squared. Now, what do I do? If I continue reading, they said in the domain. What is my domain? My domain is minus 0.5, right? So I will choose minus 0.5 to be my root. Okay? I'll choose a number less, a number greater. For example, minus 1 and 1. If I substitute minus 1, what will happen? 3 over 2 times minus 1 plus 1 squared. I will get a positive answer. And if I substitute 1, what will I get? I will get also a positive answer. If I got positive answer on both sides, that means for sure it's what? It's increasing all the time. Now, how do I find out if it's concave and not? You need to do the double derivative. So let us do the double derivative together. For this, to do the double derivative, again, it's u over v. So you do u prime v minus v prime u over v squared. So u is 3. U prime is 0. V for me is 2x plus 1 squared. Okay? And v prime is what? V prime is 2 times 2x plus 1 to the power of 1 times, don't forget, the derivative of inside, which is what? Which is 2. Which is 2. Okay, so now I need to do u prime v times v prime u. So 0 times 2x plus 1 squared minus v prime u, 4 times 2x plus 1 times 3. All of it over 2x plus 1 squared. This goes bye-bye. So now I'm left with what? With minus 4. Minus 4 times 2x plus 1 times 3. So minus 12 times what? 2x plus 1. Oh, no, this is... Okay, we need to square it now. So all of this is squared. So what will it be? 2 times 2, which is 4. Now I can cancel this one with this, and it will be what? Minus 12 over 2x plus 1 to the power of 3. So this is what my final answer looks like for the double derivative. So now, again, I will choose my domain, okay, as the... my root, okay? So minus 12 over what? Over 2 times what? If I choose a number less than minus 5, so example, minus 0.5, for example, minus 1, and a number greater. So 2 times minus 1 plus 1 to the power of 3. I get a positive answer. If I substitute 1 instead, I'll get a negative answer. That means it's concave up for any number less than minus 0.5 and concave down for any number greater than minus 0.5. So now, how do you find the x and y intercepts? We need to go back to the original equation. For the x-intercept, you need to make y equal to 0. So 0 is equal to x minus 1 over 2x plus 1. Move this to the other side. 0 times anything is 0. So now you're left with 0 is equal to x minus 1. That means my x-intercept is 1. And my y is what? My y is 0. Always for the x-intercept, y is 0. And for the y-intercept, x is 0. So now for the y-intercept, I substitute 0. 0 minus 1 over 2 times 0 plus 1, which is basically minus 1 over 1, which is what? Which is minus 1. Now I have all of my information. And I will put in like the following answers. From infinity, right? It's coming from infinity. And then what's happening? It's increasing. Then it's coming, sorry, actually it's preferable to look at the x and y intercept. First of all, y intercept is at 0 minus 1. So I need to look where is my y intercept at 0 minus 1. That means it needs to be at which point? At this point over here. So far, only two graphs follow. So this is wrong and this is wrong. My x intercept now is where at x equals to 1. So my x-intercept is at 1. Here is 1. So this does not follow. That means this is wrong. And what's my answer? This is my answer over here. We'll move on to question number 12. The y-intercept. How do you find the y-intercept? That means x is 0, right? So y is equal to 2 times 0 minus 5 times 0 plus 4. That means y is equal to 4. And my x is equal to what? My x is equal to 0. We'll move on to question number 13. They want this function admits what as a horizontal asymptote. We check the numerator and denominator. Numerator is less than denominator, so directly y equals 0 is my what? My horizontal asymptote. We move on to question number 14. Okay, so here they're looking for an oblique asymptote. That means my numerator should be greater than my denominator, which is true. So now what do I need to do? I need to divide. So 2x squared minus 2x minus 6 divided by x minus 3. 2x squared divided by x, that's 2x. 2x times, let me change the color. 2x times x, that's 2x squared. 2x times minus 3, that's minus 6x. Then you change the signs. What am I left with? I'm left with 0 and 4x. 4x divided by x is 4. 4 times x is what? Is 4x. 4 times minus 3 is minus 12. Then you change the signs. And then what do you get your answer to be? Your answer is 2x plus 4 is what is your oblique asymptote. And what's the remainder? Your remainder is, what's your remainder? What's 12 minus, my remainder is going to be 6 over x minus 3. We'll move on to question number 15. The function y equals fx equals 6x over x squared minus 3x plus 2 admits what as vertical asymptotes. For the vertical asymptotes, you take the denominator, mod 5, 3, 1 minus 3 plus 2. What do I get as an answer? I get two answers, which are 2 and 1. So these are what? These are my vertical asymptotes. We move on to question 16. Okay, this is a big question, but it's fine, we can do it. Here we don't have any exceptions. We don't have denominator, we don't have radical, we don't have radical denominator. That means my domain is all real numbers. So as x approaches infinity, what happens to my y? So I take my highest value, 5x, 4. As x approaches plus infinity, I will get a positive infinity. As x approaches minus infinity, I will get plus infinity as well, right? So plus infinity, plus infinity. The curve has a local minimum and local maximum and saddle point. To find these values, what do I need to do? I need to first take the first derivative. So it will be 20x3 minus 12x squared. Then I need to find the roots. I can find the roots by doing mod 5, 4. So 20 minus 12, 0 and 0. So I will get my roots to be 3 over 5 and 0. 0 and 3 over 5. Now what do? I choose a number less than 0. For example, minus 1. A number in between. For example, 0.5. And what's 3 over 5? 3 over 5 is 0.6. Okay, 0.5 works. And a number greater, for example, 1. Now I substitute 20 times minus 1 to the power of 3 minus 12 times minus 1 squared. I will get a negative answer. If I put instead now 0.5, so 20 times 0.5 to the power of 3 minus 12 times 0.5 squared, that's gonna be a negative answer, and then if I put 1, it's gonna be what? It's gonna be a positive answer. What does this mean? This means I have a saddle point at 0, and at x equal to 0.6, I have what? I have a local minimum, because it goes down and then it goes up again, so a local minimum. Now the curve has 2 points of inflection. How do I find the points of inflection? I need to do the double derivative. So I need to derive this again. I will get 60x squared minus 36x, right? Now I need to find the points of inflection, so I need to find the roots. I need to do mod 5, 3. So 60 minus 36 and 0, I will get my two roots to be 3 over 5 and 0 again. Sorry, was it 3? Mod 5, 3. 60 minus 36, 0. Oh, I did a mistake, because this is squared. Okay, so that's going to be minus 24x. Now, mod 5, 3, 60 minus 24, 0. There we go. I will get my two roots to be 0 and 2 over 5. Okay, so now I need to see if I substitute a number less than 0, for example, minus 1, a number in between, for example, 0.1, and a number greater, for example, 3. So, 60 times minus 1 squared minus 24 times minus 1, I will get a positive answer. When I substitute 0.1, I'll get a negative answer, and when I substitute 2 over 5, I will get a positive answer. That means I have 2 inflection points, one at 0 and one at 2 over 5, which is 0.4. Now my y-intercept and x-intercept, I go back to the original. For the y-intercept, my x is 0, so y is equal to 5 times 0, 4 minus 4 times 0, 3, which is what? Which is 0. So when it's 0, then it's 0. My x-intercepts are, that means I need to do what? I need to solve this equal to 0, because my y should be equal to 0. So 5x4 minus 4x3 is equal to 0. So take out the common, which is x cubed times 5x minus 4. That means my two roots are x is equal to 0 and x is equal to 4 over 5. What's 4 over 5? 4 over 5 is 0.8. That means my two x-intercepts are what? Are x is equal to 0 and x is equal to 0.8. Now what do I need to do? First of all, I look at my x and y-intercept. At my y-intercept, what do I have? My y-intercept is at 0, 0. So it needs to be here, 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 and here. All of them have it. My x-intercepts are 0, 0, and 0, 0.8. So I need to find, where is it 0, 0.8? Here is 0.8. And here is 0.8. So that means these are wrong because they don't have. Then what do we know as well? That means I'm eliminating my answers up to these two. Then I go up. What do I have? I have a local minimum at 0.6. What does this mean? That means at the point 0.6, which is over here, I reach the minimum point. This here is a maximum, so I don't want this. So this is why this is my answer. Okay, I'll move on to question number 17. What does it say? They want the x-intercepts of the function. How do we find the x-intercept? You need to make y equal to 0. 0 is equal to 3x squared minus x cubed. You take out the common, which is x squared. So 0 is equal to 2 x squared times 3 minus x. That means x is either equal to 0 or x is equal to 3. Right? And my y is always what? My y is always 0. Question number 18. Oh my goodness, very long. It's fine. What did they say in question number 18? Consider the function, whatever. They want the domain of definition. I have a fraction, right? So my denominator is my domain. I'll make it different than 0. That means x is different than 1. My vertical asymptote is my denominator equal to 0. That means my denominator equal to 0, x minus 1 equals 0, x is equal to 1 is my vertical asymptote. Now we look at the numerator. Numerator greater than denominator. That means I have an oblique asymptote. I need to divide x squared minus x minus 6 divided by radical x minus 1. So it's going to be x squared divided by x is x times x is x squared, x times minus 1 is minus x. Change the sign. 0, 0, minus 6. I can't divide anymore. So my oblique asymptote is what? Is y is equal to x. Now, I need to take the first derivative because they want to know if it's always increasing. So I need to take the first derivative of what? Of this. How do I take it? I can very simply simplify it. First, I can find the roots of the numerator. Mod 5, 3 it's gonna be 1 minus 1 minus 6. So my roots are 3 and minus 2. That means x minus 3, x minus 2 over what? Over x minus 1. Or no, actually no need to do this. Didn't I already divide? Do you remember when I divided, what did I get as my answer? I got y is equal to x. But I had a remainder of plus 6. So plus 6 over x minus 1, right? So don't forget, what did I do? I divided, I got my oblique asymptote, which is x. Now what's my remainder? My remainder was 6 over the denominator, which is x minus 1. Now I need to take the derivative of like this and then the derivative of this. So y is equal to 1 plus 6 over x minus 1. It's going to be, you can bring it up, so 6 times x minus 1 to the power of minus 1. So when you do the derivative, it's going to be x minus 1 to the power of minus 1. It's going to be minus 1, x minus 1 times the derivative, so to the power of minus 2, times the derivative of inside, which is 1. So that means it's going to be 6 times minus 1, x minus 1 to the power of minus 2. So minus 6 over x minus 2, minus 1 squared. Okay, so now they want to see what? They want to see if it's always increasing or decreasing. So please remember this. The graph of f is always increasing. How did they get this? Y equals 1 plus minus 6 over x minus 1 squared. Okay, so now I need to find the roots. That means y is going to be equal to 0. So if I move this to the other side, minus 1 is equal to minus 6 over x minus 1 squared. So minus 1 times x minus 1 squared is equal to minus 6. So what does this mean? This means that x minus 1 squared is equal to 6, right? So now what can we do? We can expand. So x squared minus 2x plus 1 is equal to 6. Move 6 to the other side, so it's going to be minus 5 is equal to 0. So then we do mod 5, 3, 1 minus 2 minus 5. I will get two roots, which are 3.44 and minus 1.44, right? Actually, no need to solve it. We can just keep it like this, right? And then what can we say? We can say for whichever value of x I put, I will always have what? A positive answer. That means my graph is always what? My graph is always increasing, right? So this is why it's always increasing. Now they want to see my y-intercept and my x-intercept. My y-intercept means x is 0. That means it's going to be minus 6 over minus 1. So it's going to be 6. My x-intercept means what? My x-intercept means that y is 0, right? So if y is 0, that means it's going to be x squared minus x minus 6 over x plus 1. Move this to the other side. Anything times 0 is 0, so it goes bye-bye. Now I need to solve this. You can do mod 5, 3, right? Mod 5, 3, 1 minus 1 minus 6. You will get what? You will get two answers where x is equal to 3 and x is equal to minus 2. And of course my y is 0. So now I need to find what? I need to find y-intercept 0, 6, 0, 6, not 0, 6, not 0, 6. So we eliminate these two, right? Now I'm left with these. What do I have now? I have two x-intercepts. One of them is minus 2. Another one of them is 3. So this is wrong and this is my correct answer. Now I'll move on to the last question, which is question 19. They want the x-intercept. How do we find the x-intercept? We make y equal 0. So 0 equal 18 minus 2x over 6x plus 1. I'll move this here. So what will it be? It will be 0 is equal to 18 minus 2x. So 2x equals 18. That means x is equal to 9 and my y for sure is 0. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.